As I have taught more and more nature-based workshops for conferences at private preschools, childcare centers, I have noticed that the one subject that teachers are most reluctant to teach is science. Some teachers might be worried that they lack their own understanding of science concepts, and therefore they don't want to dive into these concepts with children. They don't want to give any wrong answers, right? They might worry that children's curiosity is going to lead to all of these questions that they don't know how to answer. Even worse, teachers are convinced that science requires a whole lot of prep. You got to have the stuff for experimenting. And then once the children get done with it, there's going to be all of that stuff and a big mess to clean up. But unfortunately, I think that these reluctancies to teach science stem from some misconceptions about what science really is. Hello, I'm Nicole Trevillis-Frabel, and this is Wildwood Teaching. And today I want to tackle 4 of the biggest misconceptions about teaching science to preschoolers in the hopes that this might convince some more people to get out there and dive in. So, misconception number 1 is that science is difficult and complicated. And we're just overthinking it, especially for early childhood learners. So the National Science Teaching Association recommends that for early childhood, rather than focusing on specific concepts about life science, earth science, physical science, what we should be focusing on is scientific reasoning and inquiry. We don't need to give them the facts. We need to help them with their process of science. The position statement specifically mentions that natural environments provide, and I'm going to quote here, read the quote, opportunities for children to examine and duplicate the habitats of animals and insects, explore how things move, investigate the flow of water, recognize different textures that exist, make predictions about things they see, and test their knowledge. And then the statement goes on to explain that while children can learn scientific skills through informal processes, kind of on their own, they also benefit from intentional experiences provided by adults and a whole lot of time to question, explore, investigate, make meaning, construct explanations, and organize their knowledge. You know what those things are? Scientific method. So my favorite example of this is taking a group of 2s into the forest, and we're hiking in, walking along our path, and as we're hiking, every child is picking up a stick. And so as I'm at the front of the line, leading the line through the forest, I'm thinking, once we get to our clearing, what can we do with the sticks, right? They're already interested in the sticks. I'm not going to convince toddlers to put them down. What can we do with the sticks? Maybe we could do some sort of gross motor thing. We could put our sticks on the ground, jump over them, like walk in a line, following them. But as soon as we get to the clearing, which is on a slope, one little girl drops her stick, watches it roll down the hill, and excitedly chases after it, picks it up, runs back up the hill, drops it again. Oh, this is better than what I was thinking. So I pick up a stick and I walk to the top of the hill. I drop my stick and it goes nowhere. And so I express this to the children. I want my stick to roll like Annie's, and mine didn't roll. And as I'm going to get another stick, sweet little boy comes up, hands me a stick that is much thicker and straighter than mine. And so I'm like, thank you. And I drop the stick. Oh, this one rolls. Wonder what's different. So pretty soon, all of the toddlers, there are probably 8 of us, right? We're picking up sticks, we're dropping them, we're testing the sticks, we're giving language to it, right? Oh, so this one's kind of like bent in the middle and it doesn't roll, but the one that's really straight is rolling straight down the hill. I wonder what other sticks could we find that can roll? Why doesn't this one roll? My first one was really skinny. I don't know if it had enough weight to get down the hill. And then our next session, all I did was I got out some ramps made from gutters and a whole lot of other natural materials, pine cones, pebbles, more sticks, right? And we tested out some theories, right? We ended up changing the slope of the gutters as well to help us. So an informal process then became supported by teachers in a more formal process. Right? Misconception 2. Science is messy. Well, it is, but not in the way that we're thinking, not in materials, right? Because as you can see from the stick example, science doesn't necessarily need to involve making a mess. A good number of concepts can be explored without the need for chemical reactions, which is what causes the mess, right? You can explore magnetism. You can explore static electricity. You can explore balance. You can explore force through simple machines. You can explore light and shadow. And all of these concepts, right, can be explored simply by teachers gathering objects and creating some invitations to play. Now, of course, right, we want to remember that in order to help children through these processes of the scientific method, right, if we want to support their questioning, support their exploration, support their investigation, support how they make meaning, how they talk about what they're doing, how they organize their knowledge, then we need to be actively involved in the play. And again, I have a favorite example of this. Simple setup, right, is one of my co-teachers set up on our outdoor easel, in the tray of the easel, flashlight and some objects. Some were natural, right? So we had pine cones, we had pine needles. We had then also some man-made objects, right? Pieces of cellophane, whatever she could find, along with a flashlight. And the idea was for children to explore light and shadow. But of course, they wanted to share their findings with us, right? Oh, Nicole, look at this, look at this. This one makes a colored shadow. Oh, now we can bring in more objects to explore the difference between transparent, opaque, and translucent, right? Or Nicole, did you see, like if I shine the flashlight, you want to see my magic trick? If I shine the flashlight on the mirror, look, it looks like there's a spot of light on the ceiling. Now we can study reflections. Right, and bring in more objects and have more directed maybe activities. And if somebody noticed this, what else could we figure out? We ended up talking about rainbows. We ended up talking about color mixing over the course of a month or so. Right, this one simple provocation led to a whole bunch of investigations that children were doing individually that we were then doing as picking up as class as well. Misconception 3. Science is about numbers and established facts, and teachers need to give the children the right answers so that they can remember it for later. But that's not it. This is where science gets messy, right? Science is about the questions. Science is about the explorations. It is about the processes. And I think too often we teachers confuse the actual science for something that we are doing and imparting, right? A bunch of facts and knowledge that we are imparting to the children. So, for example, we might, you know, mix baking soda and vinegar in front of the children, and they watch the volcano explode, and they ooh, and they and this is so exciting, and then we stop there, right at that excitement point, right? Or children get stuck, right? They're trying to build a boat out of sticks and leaves, and it sinks. And instead of letting them be in the muck, right? Letting them test something out, get it wrong, retest it, when we tell them the answers, right? Oh, your sticks are too heavy, or the leaves aren't waterproof, or it has holes in it that are letting the water sink in. But science is all about the curiosity. It is all about the hypotheses. It is all about the testing and the experimentation, the tinkering, the engineering. It's learning how to think critically and follow some logical processes. Right? It's about children introducing variables, right? That what if? And then testing things and discovering, oh, okay, this is what if. So instead of doing the science for the children, we need to be their guides through the scientific process. So last spring, we did have a group of children. We were down by the creek who were trying to build a boat that would float down the creek. And it wasn't working. They weren't getting it right. But frankly, by spring, they didn't need me to do anything but observe their processes because they knew it from the rest of the year, right? They knew all of the questions that if they hadn't known it, I would have been asking, right? What have we tried so far? What do we notice about what's happening? Why might this be happening? So what else could we try? And honestly, I'm going to say that I don't remember whether or not they actually ended up being able to build a raft that moved in the way that they wanted it to. But much like process art, the end product is not the point. It's learning how to get there that matters. All right. Misconception number 4, that science can be contained in a single lesson or period or as a separate discipline. All of this exploration and experimentation can happen anytime. So that science, that process, if we're thinking about it as a process, can overlap any subject. So for example, I just had some children hypothesize that every single person in our class has an A in their name. And they were thinking about their name and their person next to them. They both had A's in their name. So logically, right, everybody has an A in their name. So this is something that we can test out, that we can explore further, that we can go back and find a method for how do we look at all the names and determine, is this true? Right? Or I've had children problem solve how to get water from our mud kitchen all the way up the stairs and to the sand pit about 50 feet away, right? Because they wanted wet sand, right? So this is then how do they figure out how to do it, right? Without dropping the water. This is science overlapping your physical motor skills, right? Again, it's figuring out a process that works. Likewise, exploration and experimentation cannot be contained in a single 20-minute, this is science time, period, right? Children need to be able to return to the same materials, the same problems again and again, right? To get stuck in the muck for as long as it takes until they are satisfied with the result, which might not be an adult finished product, right? We might it not may be a new aha, right? This is what I learned today, and I'm satisfied with that. I figured something out. I did a magic trick. I figured out how to do a magic trick with the reflections, and I am satisfied, and I just want to show it to people, right? And like I said, those flashlights, those objects, they stayed out for a month. This is an extended period of time where then we teachers kept bringing new ideas to it based on what we were observing the children doing. So the children were also bringing new ideas to it. And so I hope that this little review about these 4 misconceptions, right, that science is difficult, hard to grasp, that science is messy, that science is always about imparting established fact, and that science can be contained in a single short lesson in a short amount of time. I hope that this helps boost some teacher interest and confidence that they really can do science with preschoolers, because preschoolers are constantly engaging in the scientific method, right? We just need to be around to facilitate and explicitly name the process for them. So that is what I've got for you this week. Next week, I will be looking at rain as a loose part and some ideas for how you can play around with rain, definitely including some science processes in there. So I will see you there.